So today we will be graphing and verifying the formulas for perimeter and area of an equilateral triangle. So first we have to construct our equilateral triangle. So we're going to choose our circle tool. We're going to create a circle. And then this outside point is going to serve as our center for our second circle. And make sure that the outer circle for the the outer point for the second circle aligns with the center of the circle we made previously. So like that. And then deselect that, and then we're going to label our points. So we're going to label that A. This one we're going to label B. So now we're going to get a point and we're going to place it on this intersection of both circles. So make sure both circles are highlighted. And we're going to label that point C. So now we're going to choose all our points. We're going to connect them with line segments. And you can go ahead and hide both circles. We're not going to be needing those anymore. And now to verify that this is an equilateral triangle, you choose a side without the points. So then you go to measure and length, and you do that for all three sides. So as you can see, this is an equilateral triangle. All its sides are congruent. And now to find the perimeter and the area, we're going to select all our points in order. We're going to go to construct and triangle interior, and then you'll see that it will highlight the inside of your triangle. So keep it highlighted and go to measure and perimeter. And now we're going to highlight it again and go back to measure and go to area. So now we have all our key pieces of information. So we're going to get rid of these two since we're not really going to be using those. And we are going to create a table. So to create your table, click the measurements in order and go to number and tabulate. So it gives you this table right here. And then to add data to our table, we keep the table highlighted and go to number and add table data. And we're going to want to select add 10 entries for every 1 second. So we're going to do OK. And then we're going to drag the equilateral triangle so it will fill in our table. Okay, so now we're gonna, to graph our table or our function, we're gonna go to graph and, oops, make sure everything is unhighlighted before you select. So select your table, go to graph, and plot table data. And as you can see, your default is X and Y. So in this case, your X is gonna be your side length, and your Y is your perimeter. So we're going to graph that. So as you can see, it's a straight line. We're gonna select the center point, and then we can select any other point on this line, and we're gonna construct a ray. So now we're gonna keep the ray selected, and we're gonna find the slope. So in this case, the slope is 3, and that makes sense because whenever you're trying to find perimeter, you're basically multiplying the side length by 3. So to confirm this, we're going to plot a new function. So to do that, we go to graph, plot new function, and we're going to do 3x. And in this case, x is your input, which is your side length. So 3x and then okay. And as you can see, all the points lie on that line and it aligns with the ray as well. So now we're going to be doing the comparison between your side length and your area. So you're going to want to erase all the points you created and your axes just so it doesn't get confusing. And we're going to be doing the same steps we did earlier. So we're going to select our table. We're going to go to graph and plot table data. So now we're going to change our y value. So we're going to keep the x the same, which is what we want. We want the length of one of the lengths of the triangle. And we're going to change our y to the area. So click OK. So now, as you can see, we have sort of a parabola shape. Well, half of a parabola. And now to verify it, we are going to plot a new function. So we're going to graph, plot new function, and we're going to plug in 0.5. And this is because when you do the formula for a triangle for area, it's 1/2 base times height. So that's where the half comes from. And then we're going to do x, a little caret, and then 2, and that's x squared. And the x squared comes from you multiplying the length of the height and the length of one of the sides. So that's why it's squared. So then we're going to click OK. And as you can see, the points lie on that parabola that we just created. So that's how we can verify that the 3x and then the 1/2 x squared actually fit with how we find our perimeter and area for an equilateral triangle.